Welcome back, engineering design students. Today we are going to be coding our LCD screen. So please get to this point. This is what we wired on day one. And I am not using a potentiometer. I am using a 470 ohm resistor for my contrast. If you have a potentiometer, just quickly make sure the potentiometer is set to where you can actually see the contrast. It would be a real bummer if the only reason your code doesn't work is because your potentiometer, is set to dark. So I recommend just using a resistor while doing the coding part, and then putting the potentiometer back in once you know your code works. And to do this well, we are going to have to remember what the Arduino needs to know. And if we look at the Arduino, let's zoom in just a smidge more. The Arduino, there are 6 ports being used. There's 1 and 2, and there's 8, 9, 10, and 11. That's how mine is wired. I recommend you wire yours the same, or if you have something different, really listen in, make sure yours are doing the right thing at the right time. So we'll start with pin 1. Pin 1 connects to register select. Register select tells us which of the 16 blocks on the top and 16 blocks on the bottom, because it's a 16 by 2 LCD screen, which one should we be writing to? So that allows us to do things like indent or skip a line. And pin 1 is going to control the register select. Pin 2 is going to control the enable. That wakes up the LCD and says, hey, data's coming. And where's the data coming from? That's pins 8, 9, 10, and 11. That's going to be data ports 4, 5, 6, and 7. So 1 says where to write, 2 wakes up the LCD and prepares it for the data coming out, 8, 9, 10, and 11. So now what we need to do is we need to program this chip to know that, because the chip has no idea. I can yell at it, but until the code tells it, it knows nothing. So now we are going to click on code, the code button, and here comes the pre-programmed code. We are not going to use this at all. And this is plug and play code, and I'm not a big fan of plug and play code. I'm more in the real deal thing. So we're going to click on this down arrow, and we are going to click text. We're actually going to type in our own code. So let's click on text, and it's going to say, but wait, you'll lose all the beautiful blocks that I built for you. I say, yeah, that's fine. They're kind of ugly. And all this pre-made code pops up, and we're not going to use that either, because you know what? We're smart people. We can figure this out on our own. So we're going to. So delete everything. And now if you hit start simulation, you'll get a bunch of errors because it'll be like, where's all the code? So let's close that and let's give it some code. First thing is, there are 2 things that every Arduino code needs. So what I'm going to do is I'm going to put 2 forward slashes right there, and that means that I'm going to write comments. The computer skips right over this line. If there are 2 slashes, it says, computer, don't read whatever comes after this and skip on to the next line. So the first thing is you have to have a function called setup, and that prepares everything before loop runs. So anything that the computer needs to know before loop runs, wait, what's loop? We'll get there in a second. Anything the computer needs to know right off the top, right off the bat. So that would be things like declaring variables and setting them to numbers and telling it what pins you're going to tell it needs, and just kind of wrapping its mind, preparing its mind for the problem that is coming. And then, so I'm going to skip a line, and I'm going to come down here. I'm going to write another comment, 2 slashes. So again, comments are the way that humans write to humans, and the computer skips right over it. Loop means do this code over and over forever. And then it's supposed to just loop. Do whatever code follows the loop. Just keep doing that. And so in our code, or in our previous code, that would be things like make an LED blink, or make an LED fade in and fade out, right? All that kind of stuff. And it just kept doing it. We didn't have to say, do it 5 times. We just said, do it once. And then loop said, just kept it going. So if we clicked on start simulation, it would just flash and flash and flash and flash forever. And that's what loop does. And every Arduino code needs a setup and needs a loop. So we are going to start with setup. So setup is a helps if you spell it correctly, is a function, and what that means is you can send in information. That's what these two little parentheses are for. Now we're not sending in any information, but you could, right? And then in programming language, there's these things called open bracket and close bracket. And what that says is the open bracket says this function setup does everything between these two brackets. So the first thing you need to do is you need to have an open bracket. It's customary that the function and the open bracket all are on the same line right after each other, no spaces. And then you have a close bracket. And then anything I type here will happen during setup, because this line is between the open bracket and the closed bracket. But it's a comment, so the computer skips over it. Now, if I hit go, it's actually going to throw an error and say, whoa, 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 hey there. Hey, setup needs a thing. It actually says here, if I look, it says int setup. And what that says is, hey, every function, such as setup, returns a value. And it has to return a value, and you have to tell it the value it's going to return. Well, ours doesn't return anything. Now, functions can, such as if this were a function called add, it could return the sum of the two numbers you sent in, right? Or if it were multiply, it could return the sum of the product of the two numbers that are sent in. But our setup isn't going to return anything, so we use this special word void. And void tells the computer, hey, I'm going to do a job, but I'm not giving anything back. There's going to be no output. This is just a do thing, not a do and tell me about it thing. So there's no tell me about it. So we have to write void. Now if we hit start simulation, we'll get whole new errors about loop. Well, that's okay. That's okay. We haven't gotten to loop yet. Okay. And now loop is going to look a lot like it. So setup currently doesn't do anything because the brackets are empty. But every Arduino code needs to start with void setup, parentheses, where I could send in information, and then an open bracket, close bracket. And the loop is going to be the exact same thing. Void, loop isn't going to send out any information, such as the number of times it went through, right? You could have a counter counting and be like, every time you go through, tell me about it, But loop's not going to do that. It's going to send nothing. And it's called not lop, it's called loop, and it needs a place where I could send in information, but I'm not going to. So I leave, there's nothing here. I could send in information in this spot, but I'm not going to because it doesn't need any. I open, double enter, I close. And now if I hit start simulation, no errors except that nothing happens. And it says, it's trying to debug because it says, just FYI, this is really dumb code. It's not bad code, but it's dumb code. Are you sure you want to do this? And I click off the debugger, click off the simulation, and I say, well, I'm just setting it up. Jeez, give me a second. My word, get off my back. Now this code, you could actually just kind of copy and paste this and drop it into a Google Doc, because every single code will start with this. So you may just want to save this code so you don't have to retype this ever. If you ever program an Arduino, you absolutely have to have this. But then you would change what goes inside setup and what goes inside loop. So you may just want to save that. Okay, now we are ready. So first thing we need to do is we need to actually tell this Arduino, hey, we're not just like making an LED blink. We're actually working with an entire LCD. Oh my gosh. Holy cow. Now, with Arduino are a bunch of things called libraries. Libraries are large packets of information you rarely use. That's what libraries are. Uh, and the easiest kind of metaphor for this is if you think of like video games and individual worlds in that video game. When you first start the video game, it doesn't load the final world. It only loads the first world because that's the world you're dealing with when you first start a video game. And it doesn't load the second world until you've completed the first world. Then it takes the first world, puts it away, and loads the second world, right? So you can think of each of those worlds as libraries. They're big, huge packets of information, but you don't use them all the time. In fact, you often don't need most of them. You know, that final world, depending on how good you are at a game and how often you play it, may never get used or may get used in like a year if it takes you that long to get through it. So what computer programmers do is they say, hey, there's a bunch of information like a world in a video game, and it's all related, but it's rarely used. Let's call that a library. And then you have all these libraries that are coded, they're in there, but they're not loaded. They're not ready to go right now. And you have to go and you have to tell the Arduino, hey, you already know a bunch of information about LCDs, and I need it now. Now, we didn't have to do that when we were just blinking LEDs because LEDs don't need to know anything about an LCD. But now we have to say, hey, I actually need you to include some information for me. So what we're going to do is we are going to include a library. Now the library that we're going to include is actually the, and I'm just going to highlight it right here, liquid crystal.h library. So there it is, liquid crystal.h, and that has to be in brackets. So liquid helps if I learned how to spell crystal.h library. Now if I hit start simulation, do I get an error? I don't, because we did it right. Yay! So now what this line of code does is this says load everything you know about LCDs. That's what this does. So now there's a whole bunch of functions that this chip already knows, and we've loaded them all in. Yay! Woohoo! So the first thing we've done is we've prepared this chip. We've loaded the LCD world into our video game so that we can use it right now. Now, if we look, and I've cheated a little bit, first thing we have to do is we have to tell the computer, and I have it all kind of right here. So I'm actually going to copy and paste it. Oops. Now what we have to do is when we first load the liquid crystal libraries, what we have to do is we have to tell it immediately, okay, liquid crystal, that's the library. What do you want to call the information? Because you have to reference it, and we're going to call it LCD. Now we could call it Bob if we wanted to. We could call it Dave. We could call it the abstract concept of honor. We can call it anything we want. Most people would just call it LCD. You just need a name so that you don't have to type in liquid crystal display all the time. And it's just one instance of it, right? This Arduino could be linked to two liquid crystal displays. So we would call one LCD1 and we'd call the other one LCD2. So we're just going to call this LCD. And then do you notice anything about these numbers that are inside of it? Hey, those are the pins. The first number is the pin for register select. Oh, so I'm saying that pin 1 is going to tell you where, oops, I mistyped this, where to print. Oops, typo. Pin 1 is going to tell the LCD where to print. So I have it as pin 1, comma. The next thing is enable. Pin 2 will tell the LCD when a command is coming. It'll wake it up and enable it, and that's what I list here. Now, if I wanted that to be pin 3, I would just change pin 2 over to pin 3 and then change this to a 3. So I can choose what pins I want to be here. I've chosen 1 and 2 to be the where to write and when to wake up, but they could be 0 and 5. They could be 3 and 12. They can be anything I want, but I chose 1 and 2. And then the next 4 pins are, hey, this is where the data is going to go. So we're going to use these 4 pins to send information. And this library is already set up for if I give it a name and put 6 numbers in, it knows the first number that I give it is where to write. The second one is how to wake it up. The third one is the first data point, second data port, third data port, and fourth data port. So that's this library that I loaded this ability, and now I have to instantly, right after I load the library, I have to use it. So now if I hit start simulation, I shouldn't get any errors. It should be like, okay, totally. And there it is. It doesn't print anything yet, but it now has the ability to print. Isn't that nice? And now, let's print. Okay, so we're going to be talking to the LCD. Oh wait, what's LCD? Oh, that's right, that's what I'm calling my liquid crystal display. If this were Bob, I would type in Bob, right? But it's not Bob, it's LCD. So we'll do LCD dot, and again, first thing I have to do is I have to begin. Now begin is a very specific function that lives inside the liquid crystal library. Begin says, okay, I totally get that you have an LCD, but how big an LCD? Because is it a 16 by 2 or is it one of these guys? Because an Arduino could run one of these, but it would be a different type of, it would be different numbers that go into begin. By doing 16, that is how many cells across, how many cells across it is, and 2 says how many cells tall it is. So I do a 16 by 2, and that tells it that, oh, you got a 16 by 2 LCD, totally. And then what I'm going to do is I'm going to set the cursor. And set cursor is another function. Set cursor says, where do you want it to go? Now if I look here, I've already set it. Set cursor right here says the first number tells you how far over, and the second number tells you how far up or down. Now in computer science, we always start with zeros. So the top left corner, this cell right here, is not 1, 1, it's 0, 0. 0, this first number here, says how far over, and I've said go all the way here to the left. If I want to go in 4 cells, I would change that to a 4, and that would be 4 cells over. This 0 here says, which row do you want? Do you want row 0 or do you want row 1? And I'm saying I'd like to write at the top. So what this does is this sets the cursor and says, I am now, whatever I write is going to start right here. And then I would like to have my LCD print. And I'm going to have it print whatever is between these quotes. So again, print is a function that is part of the liquid crystal library, which I loaded in. It knows it, just as begin and set cursor are also in that library. Print is in that library, and anything between these double quotes, I can type in. So I'm going to type in hello. And let's just see what happens if I hit start simulation. Hello! And let's see how far over. 0, 1, 2, 3, 4. Oh my gosh. It's on spot number 4, which is actually the 5th spot, right? Because it starts at 0, 0, 1, 2, 3, 4. And if I stop simulation and I make this a 1, where do you think it's going to print? It's still 4 over, but now what is 1 going to do? 1's going to, oh, put it at the bottom. That's right, because this is row 0 and this is row 1. So now I'm going to stop simulation and I am going to put it in the top left corner just to prove that it's in the top left corner. I hit start simulation and now it's in spot 0, 0 because that's where I set the cursor. And now I would like to write under it. So lcd.set cursor. I have to say where I want it to be. Oh, I forgot to tell you, every line inside of a function has to end with a semicolon. Oops, I did not make that clear. I'm not the greatest teacher, what do you know? Functions don't need because they have brackets, right? So the bracket kind of is the semicolon for this line, but every line needs a semicolon. What about include? They don't need it because it's included and it's special. But this line needed it, right? Okay, so set cursor. Let's see. So now I want to move the cursor down. So I don't want it to move over. I want it to be all the way to the left, so it's going to go 0 over, so we'll start right here. But I do want it to go down. So hello should be, I point the cursor here at set cursor 0, 0, and then I write hello, and then I'm going to go down, and I'm going to write something else. Let's move it over. Why not? Let's move it over to 5. So it'll be, remember this is how far over, so it'll actually be 6 over because it's 0, 1, 2, 3, 4, 5, 6, and it will be 1 down, so it should be right around here. And then I want to print some more. Oops. And again, anything between these quotes, I can write. So let's write the classic world. Okay, well, let's see if it works. Cross my fingers and... close. Oh, I'm the smartest person. I forgot to say, hey, we're talking to the LCD here. Whoops, I get typing fast sometimes. Go to lcd.print. Where's the print function? It lives inside LCD. All right. Whoops. Now, bam, hello world. And world is right where I expected. 0, 1, 2, 3, 4, 5. Bam, there it is. Now the loop, nothing. Now if I did want it to say something later on, then what I would do is I would go down to loop, and the first thing I have to do is I have to clear all this because this is all part of the setup. So it's going to run the setup first. So the first thing, right when I boot it all up, it writes hello world. And then if I want loop to print on it, I have to clear the screen. Now luckily, LCD already knows how to clear the screen because there's a function inside this library called clear. Yay! And now I would be able to print. Now if I do lcd.print, wait, Jay, you never set the cursor. It doesn't know where to print. How would it know? Well, let's see what the default is. You know, that's not creepy at all. First we'd see hello world and then see I see you. Oh my gosh, why is it flickering so much? Oh, what's going on here? Oh, that's right. It's clearing and then it's printing and it's then looping and clearing again and printing and looping and clearing again and printing and looping forever. Oh, that's kind of terrible. What if I take the clear out of there and I put it here? So I go LCD, clear, because that's what I want to clear. And what'll happen then? That's going to work out. Whoa. Oh no, now it's writing I see you forever because oh geez. This is not working out the way I want. Well, oh, hey, what if we just paused? What if we went LCD, clear, we print, and then we put in a delay of, I don't know, 1 whole second. Now, delay is not inside the library, so I don't need an LCD in front of it. It's actually pre-coded. It's one of the special words, just as setup is a special word and loop is a special word that I didn't have to pre-define. Delay is a special word that the Arduino already knows, and that is in milliseconds. And we've seen that before. Now what happens? Ah, there we go. That feels nice. But I didn't really see the hello world all that well. So let's put another delay right at the top. So now I'm going to see the hello world. That only happens once, right at the beginning. And then when we enter the loop forever, I'm going to wait a second. I'm going to clear it. I'm going to print. And then I'm going to wait another second. Superfluous, but okay. Let's see how this works. Hello world, I see you. Isn't that nice? And if we wait a second, and then wait a second, it should probably flicker and we should see it print again. Right? Now what happens if we get rid of this clear? What if we don't clear it? That's kind of a fine idea. So what I did was I made this a comment. I put these 2 lines. So now the computer's going to skip this line completely. What happens if I do this? Hello world. Oh, it tacked the I see you right onto the hello world because I never cleared it. Oh, that's why we clear it. That's right. Okay, so that's all you need to know. And remember, if you want the ICU to be somewhere specific, I can do set cursor here. So I wait a second, I clear it, and I can set the cursor and say, I'd like it to be, I don't know what, 6 over and on the second line. And now if we hit start, hello world, I see you. I don't get the whole ellipsis. Ellipsis are the 3 dots. So I could kind of scooch it over if I wanted to see the whole thing and put this as a 3. And now we now know how to ding. Day 1 showed us how to wire this. Day 2 showed us how to write on it. And that's everything you need to know. So good luck out there.